4.5 inches squared. Alright, so I have my X bars and Y bars for the individual shapes. So I have all of those index parts. And remember, this is the sigma, that's the summation symbol. Hopefully you've seen it before, but if not, it means add up all these things. So what am I going to do? For the X direction, for X bar, for the entire shape, I'm going to take my X times the area. Oh, sorry, this one's a negative area, right? Because it's non-existent. So we'll consider this negative. So that area is negative because the triangle is missing. So hopefully that makes sense. So I'll take this times this, and I'm gonna add it. So I'm summing this. Add it with the X bar times this area, which is negative. Whoops, I didn't write negative. There. And that'll be my X bar for the entire shape. So that'll change where this centroid is. So let's do that. This is going to be a long video. So getting big X bar. So it was 3 inches. This is for shape 1. 3 inches times 36 inches squared. And then I'm adding it with the area times the area of the second one times the X bar of the second one. So that'll be 1 inch. 1 inch times the negative 4.5. 4.5 inches squared. So that I just did the top part. That's this. And I'm adding it together. And then I'm dividing by the sum of all the areas. So I'll just take the two areas, 36 inches, 36 inches squared, minus adding a negative, that's the same thing as minus, 4.5 inches squared. So I'll do that. And that'll be my X bar. That'll be my X bar. So however much I go out on that from the reference axis, that's what this distance will be. So let's see. So that's shape 1. This is shape 2. 3 times 36, that's 108. That's inches cubed. And I'm adding, well, actually it changes to subtraction, right? Because of that negative there. So negative just 4.5 inches squared, and I'm dividing it by 36 minus 4.5. So I'm dividing it by 31.5 inches squared, because it's area. Well, sorry, that's cubed now, right? Inches times inches. Inches times inches squared, actually, is inches cubed. So I'll continue with this. X bar equals 103.5, and I'm dividing it by 31.5. This is inches cubed. This is inches squared. So that means this goes away. This turns to just inches. That's good because I want it to be just inches. Whoops. Whoop. Nope. Just kidding. I made a mistake. It's on shape 2, so we got to change X bar and Y bar. This actually makes sense. This centroid is the distance away from the reference axis. So, you know how I said, if this shape was all by itself, yes, that would be the centroid. However, we're thinking X bar should be the distance away from the reference axis. So if this is 1 inch, then we have this shape. So let's correct this right now. Sorry about that. We'll definitely do more examples. So if this is 1 inch, then that means this is 2 inches, right? And this entire thing is 6 inches. So if we're taking out this 1 inch, the distance away from the reference axis would be 5 inches. So that's way different. That's absolutely way different. So this X bar is actually 5 inches. So that screws up some things. That means this changes to a 4.5. I normally would start a whole new video, but this is too long, so I'm not going to start it over. Sorry. So that changes that part. So cross that out, change it to 5 inches. So that means this number changes. So I'll change that right now. What's 4.5 times 5? That's 22.5. So this will be minus 20. Whoops. 22.5. So that changes things. That changes the top number here. So that's 85.5 in the top. That makes more sense. All right. And that'll still be inches because this is inches cubed. So that's good. That becomes a 1. All right, let's review that real quick. For x bar, we calculated the centroid here, but we need the distance of the centroid to the reference axis. And that centroid to the reference axis was 5 inches. So we got that by getting the centroid. We knew it was 1 inch away from the right angle of the triangle. So yeah, that means it's 5 inches away from the reference axis. So that's also 5 inches. The area is still the same, so we're okay there. And now we'll find x bar, and that's 2.714-ish inches. So that means for this shape, which I'm going to redraw, for this shape, which looks like that, for this shape, 2.71 inches away. So this is like 3 inches. 2.7 maybe is right there. 2.71 inches. There's that axis, and since this is symmetrical across that, it's actually 2.7. We don't even have to calculate y bar. It's, if that's half, maybe that's 2.71 inches. And then there we go. The intersection is the center of gravity. So that's how you do that. Sorry about the mix-up. Hopefully it's still understandable. We'll definitely do more examples in class and before we get to our activity, which means, we're going to get to calculate stuff for actual physical things and then hang them up and see if they hang properly. So there you go. That's where the centroid is. That's the subtractive method. We didn't have to do it for the y's because it was symmetrical. If it wasn't symmetrical, then we would have to do it for the y's. Okay, I'm done. Sorry.